Major funding for this program was provided by
The Colcom Foundation, working to foster a sustainable environment to ensure quality of life for all Americans.
additional funding provided by the Associated General Contractors of America, the American Society of Civil Engineers and its Environmental and Water Resources Institute, Insituform Technologies, and the National Association of Clean Water Agencies. The following is a production of Penn State Public Broadcasting, which is solely responsible for its content.
Across America, cities and towns, homes and businesses, all depend upon one basic resource. Modern civilization and life itself would be impossible without it.
Okay, so today we're going to look at how do we get our water.
And today, it's a matter of simply turning on the tap.
So often we forget about the value of water.
Water is a commodity that is essential to life.
100 years ago, it would have been hard to imagine turning on the tap water, and now it's an expectation.
Over 300 million people live in the United States, and each person uses an average of 100 gallons of water every day.
What it takes to actually make clean water is somewhat a mystery to most customers.
So how does water get from the river into your house or here at school?
Somebody has to bring that water to us, and somebody has to take it away when we're finished with it.
The water infrastructure is vital for disease protection, fire protection, basic sanitation, economic development, and for our quality of life.
You just can't visualize all the assets that are under our feet. We have about 2 million miles of pipe in this nation. If you're walking around in an urban area, you're probably stepping on a pipe.
Our grandparents paid for and put in for the first time these large distribution systems.
And in many cases, it's not been touched since.
We're at a critical turning point. Much of that infrastructure is wearing out.
Our water infrastructure is made up of complex, underground systems that function continuously. These 10 locations take a look at the history, design, and challenges of our water infrastructure systems. Each one represents a small part of what's at stake on a national scale. But understanding the challenges starts with understanding the value of the three basic systems. Generations of Americans have never experienced living without a constant, unlimited supply of water delivered straight to the tap, or without their waste flushed immediately away.
I think people often forget because, water utilities have made it very convenient for people to get water. How important this is.
In terms of water supply, wastewater, stormwater development, these are independent technologies. But what came first most often was a water supply system. The basic system is essentially the same as we used back in the 19th century, and in some cases, some of the same pipes.
Philadelphia was the first American city to develop a water system and to take on as a municipal responsibility water delivery to all of its citizens. When William Penn laid out the city, he actually chose a spot of land that had a lot of groundwater. However, by 1730, 30,000 people lived within the first 7 blocks of Philadelphia next to the Delaware River. Well, 30,000 people caused filth in the city and polluted their water sources. the groundwater was not potable. And in 1 year, 1/6 of the population died of yellow fever. Now, they didn't know at the time that yellow fever was carried by mosquitoes, but the health issue was major in that first movement to build a water system.
So they set out to find the cleanest source of water. Although the majority of Philadelphia's water now comes from the Delaware River, early engineers found that development along the waterfront was causing pollution. So their search led them to the nearby Schuylkill River. Philadelphia developed technologies to pump water from the river into the city, and these technologies established engineering concepts that are still the basis for our water systems today.
Europeans flocked here. It was a destination point to see the new world technology. When Charles Dickens visited us in 1840, he was truly blown away by high water pressure on the 4th floor of the hotel he was staying in. Nowhere in Europe had he experienced that. This technology was doing something to support the life and the growth of the city. Philadelphia, throughout the 19th century, was the major industrial city of the United States. All of these industries used water from this system, and it served as a prototype for many American cities, including Pittsburgh and New York.
New York City went to Philadelphia and said, you know, we're thinking of developing a Hudson River water supply. What do you suggest we do? And they said, we've had a lot of problems on the Schuylkill. Don't go to the Hudson River. Go to the upland and work by gravity. And that's what New York City did. They first went to the Hudson Highlands, but 150 years later, it went to the Delaware Highlands and really diverted the water that normally went to Philadelphia to New York City. I don't think they anticipated that.
The majority of New York City's drinking water comes from watersheds in upstate New York. A watershed is the area of land where water from rain or snowmelt drains downhill into a body of water. Mountains act as a funnel to feed rivers and lakes, and in this case, reservoirs. In the New York City system, water is collected and stored in 19 reservoirs, which can hold more than a year's supply. Over 580 billion gallons of water. Almost all of the system is fed by gravity without the use of energy-consuming pumps. Valves open to regulate the flow into the 85-mile-long Delaware Aqueduct, the longest tunnel in the world. At Hillview Reservoir, the water is partitioned into another giant tunnel system where it travels deep below Manhattan. The pressure built up by gravity from the mountains pushes the water upwards toward the surface through vertical shafts. These shafts feed the water mains of each neighborhood, which branch into smaller pipes below the streets, feeding into buildings and houses, into the plumbing, and finally, after its long journey, to our faucets. Providing water to homes and industry is a monumental task, requiring immense infrastructure. But once the water is delivered and used, it must also be taken away.
It's important that the waste generated by any society not be left around. Cholera and other diseases and problems have been spread because people wound up living in filth. Even the ancients understood that you couldn't have the sewage where you lived. And the easiest thing to do was transport it to another spot. by water or a river.
Most of the first sewerage systems were on the east coast of the United States, often in places that already had developed a citywide water supply system.
In 1630, Boston was basically 3 mountains. There were very steep hills. Waste would run down quickly and dump into the harbor, and the tide would carry most of it away. Well, this worked well for a while. The problem was, as Boston wanted to expand, it started filling in the mudflats. The water could come rushing down the hill, it would hit the flat area and slow down. At high tide, it couldn't get out at all. It got so bad that the city took over, because the city has a responsibility to protect its citizens. Boston built the first modern sewer system in the United States. Ours was completed between 1877 and 1884. With this wonderful new sewer system, we were taking our filth and moving it out to the ocean. Of course, all of this was untreated. In the 1960s, we were still pumping all of our sewage out to Moon Island, untreated. We would get swimmers here, never knowing in the middle of summer why you would have a cold. Well, we were swimming in diluted sewage.
The major way to deal with pollution, at least until early into the 20th century, was through the process of dilution. The assumption was that the capacity of rivers and streams and even the seas allowed for certain levels of pollution that eventually would purify themselves. As we get later into the 20th century, it becomes clear that the volumes of waste made dilution unworkable as a single solution. And so treatment became the ways in which we deal with pollution.
To protect public health, starting in the 1950s and 60s, there was a push to put in wastewater treatment plants across the United States. Today, with evolving technologies, the waste travels through multiple stages of treatment, removing tons of solids, settling out microscopic particles, and introducing bacteria that consume and decompose the toxic material. In some plants, the water is further disinfected through the use of ultraviolet light or ozonation. These plants cost millions of dollars to construct, operate, and maintain. In population centers like Los Angeles, the scope of the task is staggering. The Hyperion wastewater treatment plant serves 4 million people. It processes 350 million gallons of sewage and removes 500 tons of solids daily. After treatment at Hyperion, what was once raw sewage is clean enough to release into Santa Monica Bay. Other cities and towns release treated wastewater, or effluent, into local rivers, lakes, and streams. As it flows downstream, additional cities may capture it for drinking water, consume it, and treat the water again. In other words, the water coming out of a wastewater treatment plant often enters the watershed, flows into intakes of drinking water treatment plants, and eventually finds its way right back to our faucets. It takes huge investments to ensure that wastewater and drinking water treatment plants function properly to maintain a safe water supply.
We made the initial investments in the plants and the pipes. But once we accomplished that, there was this great recognition that we had a series of issues associated with wet weather conditions. Storm events where all of a sudden you're dealing with a lot of water.
Large amounts of rainwater can cause flooding. Engineers developed 2 approaches to stormwater infrastructure to transport water away from the urban environment. One approach was to carry waste and stormwater through the same pipe. This combined system was less expensive than building 2 individual pipe networks, and stormwater was seen as a way to flush out the sewers. Through the 19th century, the combined system was considered state-of-the-art throughout the world and is still in use in many cities today. But cities constructed these systems before treatment was the standard, And even today's largest treatment plant doesn't have the capacity to treat the sudden volumes of water rushing through a combined system during rain. The plant is overloaded, and the excess rainwater, mixed with untreated raw sewage, is diverted straight into local waterways, creating a combined sewer overflow, or CSO. There are over 700 communities in the United States with combined sewer systems. The other approach was to separate wastewater from stormwater using two-pipe networks. This separate system simply carries the stormwater away from the city. But even separate systems pollute the watershed. In developed areas, concrete and other impervious surfaces prevent water from naturally soaking into the land. As the rainwater moves over the roads and concrete expanse, it captures trash and invisible chemicals, sending them straight to the nearest waterway, untreated. When engineers first designed America's water infrastructure, the drinking water, wastewater, and stormwater systems, they were some of the most advanced in the world. But the infrastructure is growing old, and population growth and development, particularly in urban areas, have made it difficult for original system designs to meet modern health standards and reliably satisfy demand.
Our water and wastewater systems really are engineering marvels. Because it's buried, it's invisible to us, and we tend to take it for granted. That's a mistake. Like any engineered system, it requires maintenance and periodic rehabilitation and eventual replacement.
It's so out of sight and so out of mind that we don't realize the danger we're in. People see that their roads can cave in. Their bridges are falling apart. The concern is that also the infrastructure that they can't see is falling apart. You wouldn't let your house be 100 years old and not ever do any maintenance to it. You would make sure that it was safe. 100 years ago, Teddy Roosevelt was president, and your pipes were brand new. Now, our infrastructure is old. 100, 200 years old. It's not been upgraded or fixed or replaced, sometimes ever.
If these systems are not maintained, sooner or later they're going to fail. They all have a life expectancy. If you don't maintain them and constantly check them and then do what's necessary to rehabilitate or repair, you're going to have a big problem. And they're going to collapse. They're going to fail. And all of a sudden, the water or the sewage that normally goes through them will not have any place to go. It'll back up into homes. It'll back up onto the street. It's normally out of sight, out of mind. Once it comes to the surface, it's a whole other animal.
You're talking about system-wide problems that would take tremendous human resources to correct. This is true with drinking water as well as wastewater.
But first, our top story, thousands of people are without water tonight.
A flash flood of the man-made kind.
Apparently a 12-inch pipe burst.
Take a look behind me. This water main break has shut off water to 2,200 residents.
How many breaks are you working on right now?
We have 24 breaks working right now.
In our company, Washington Suburban Sanitary Commission, we had 479 water main breaks in February, the most ever for any February.
This 10-inch water main in Willard Park is 73 years old.
At WSSC, we're having a year of record, a ramp-up slope of water main breaks that soon is going to reach exponential.
The damage has been done.
And this is the culprit.
Today, 25% of our 5,500 miles of underground water pipes has reached the end of useful life. By the year 2020, 85% will have reached the end of useful life.
What to do? WSSC is working on that costly problem right now.
It's not only true here, but it's true throughout our nation.
Across the United States, cities and towns are facing the challenge of aging and outdated drinking water, wastewater, and stormwater infrastructure. It's a national problem, but it needs to be approached system by system.
Let's frame the systems in terms of the proper context. We have around 16,000 wastewater systems. We don't have a single wastewater system. We have 16,000 of them. We have about 54,000 drinking water systems.
Issues facing New York City are very different from those in Los Angeles, and challenges facing small towns are very different from those in metropolitan areas.
We have to have water supply for health purposes, for fire protection, and the economy. Without it, things simply can't exist.
We have good health in this country in part because we have clean water, and we shouldn't forget that, and we shouldn't take it for granted.
In the late 19th century, serious waterborne disease epidemics were having devastating effects.
But then in the early 1900s, we began to treat our water. And since then, we've seen a rapid decline in the incidence of waterborne disease.
Most cities treat drinking water through filtration, chlorination, and sometimes ozonation to kill pathogens in the source supply. These are complex treatment plants that cost millions of dollars to operate, but are necessary for our well-being.
The treatment of drinking water has been called one of the greatest public health achievements of the last century. The water infrastructure itself protects the treated water until it comes out of our taps.
It's been since 1911 since we had an outbreak of cholera or typhoid in the United States. But that doesn't mean that it can't happen. It can happen. If we aren't on our guard all the time, we are vulnerable to going right back where we were in 1911.
In Milwaukee, health experts are taking a close look at the public water supply. In Milwaukee, thousands of people have been getting sick.
Private distributors of bottled water are sending extra supplies as fast as possible. Health officials blame a microscopic parasite called Cryptosporidium.
In the 1993 Cryptosporidium outbreak, over 400,000 people became ill with diarrhea, cramping, and nausea. And we also recorded over 100 deaths, primarily in the immunocompromised community, and in particular, individuals with AIDS or HIV infection.
People were beginning to experience symptoms of diarrhea. It started to become more and more widespread, so the natural spot to look was drinking water. So tests were run on the water coming out of both of our water treatment plants. And we found Cryptosporidium coming out of our Howard Avenue plant.
Milwaukee officials are shutting down one of the city's 2 water purification plants.
Cryptosporidium is a parasite that's found in the gut or intestine of both humans and animals, and found in many surface waters throughout the globe. Prior to 1993, it was not on our radar. It was not a reportable disease.
EPA standards did not safeguard against Cryptosporidium because it was an unknown threat. Once it contaminated the water supply, the treatment plant had no capability to kill the pathogen, so it spread throughout the system.
We saw an expenditure of $90 million to upgrade both water treatment plants.
Cryptosporidium was a wake-up call. It was a wake-up call for us. It's a wake-up call for the nation. Take care of your infrastructure before you have the kind of problem we had.
By no stretch of the imagination do I think we're out of the woods. Recent CDC statistics indicate that up to 32 million cases of waterborne disease occur each year in this country.
But the vast majority of waterborne outbreaks go undetected. When people first get ill, they think, oh, it's something I ate last night. They don't think, oh, it's something I drank last night.
The Milwaukee incident pointed out the potential vulnerability of our drinking water infrastructure in controlling the spread of illness.
It's incumbent upon us to try to stay ahead of the curve, but it's very, very difficult. And there's always another bug on the horizon.
In 2008, the Associated Press reported that water quality testing across the nation uncovered trace amounts of pharmaceutical compounds in the drinking water supplies of millions of Americans. The health effects of these low levels of medications diluted in our water are still being determined. But these findings further illustrate the fundamental relationship of infrastructure to health. The quality of water plays a significant role in public health, but reliable quantities of water play a significant role in public safety.
The water that comes out of the fire hydrants is the same water that you are utilizing to drink out of your own faucets in your home. So it is critical that we have the best and optimal water distribution system that we can tap into.
In the mid-1990s, the water system had just about collapsed. The district had just run into some very dire financial circumstances, and when those kinds of things happen, the very first thing that goes is maintenance of those things that one does not see.
You have hydrants that were manufactured in the 1800s. You have underground pipes, you have underground valves. They get what they call tuberculin built up. You would compare it to a 100-year-old man that has heavy cholesterol. They could be 6 or 8 inch mains, but being 100 years old, they actually may be 2-inch mains. And they reduce the amount of volume of water that's available to us.
There were a number of things that we have had to do in order to get the system back up to an acceptable standard. Replacing mains and valves and fire hydrants and other components of the system to ensure that it operates properly.
We consider both the underground infrastructure and the above-ground assets to be a part of the critical infrastructure of the city.
And if the infrastructure is not there to actually deliver that water in the volume and the quality that's necessary, then communities simply can't exist.
Infrastructure is vital to the American economy. Water, after all, is an essential ingredient in hundreds of thousands of everyday products.
Agriculture and industry use roughly 80% of the water consumed in the United States. Water is the basis for manufacturing many goods and provides the ability to clean and sterilize everything from computer chips to the surgical instruments used in hospitals.
The minute that there's not enough water for businesses, industry, and individuals, they have to go elsewhere. And when they go elsewhere, jobs go elsewhere. Your entire economy begins to suffer with the lack of clean water.
While the water infrastructure provides for our health, safety, and economy, a growing concern is that the value society derives from water has not traditionally been reflected in the price we pay for water.
When you take a look at how much people pay for water, as a percentage of median household income, it's usually less than 1%. And when you compare that to how much we pay for electricity and gas, cable TV, and internet, the bottom line is, in the United States, we don't pay a heck of a lot for water.
At an average cost of about $2.50 for 1,000 gallons of tap water, it is a great bargain.
But the rates that are being charged for water are insufficient to replace existing systems and to expand existing systems.
Because original infrastructure investments were frequently subsidized by the federal government, water pricing was often calculated without accounting for the initial cost to build the systems.
We made major investments in assets in the 50s, 60s, and 70s. And for the first 40 years of that pipe, there really may not have been many maintenance requirements. We're past that period now.
Water pricing based only on day-to-day operation and not on planning for maintenance and eventual upgrades has resulted in a considerable repair and replacement backlog.
On a national scale, if you looked at what we're spending now and you looked at the additional investment requirements over the next 20 years, there's a $540 billion difference.
So one of the greatest challenges is to reflect true value pricing so that the citizens and businesses that rely on water and wastewater infrastructure systems are actually paying for it.
Cities and municipalities across the United States are now facing this funding gap between projected revenue and projected expenses as they strive to maintain water quality and meet demand. New York is the most densely populated city in the U.S. and over 40 million tourists visit the city every year. The 1.3 billion gallons of water required every day are delivered by a system of extraordinary scale and complex engineering.
Water is essential to the economic viability of New York City. Reliable infrastructure and reliable delivery of water is a must.
You have to reinvest in the infrastructure every single minute to keep it current.
We have the stock exchange, we have the United Nations. Failure can have a dramatic impact on the nation and even internationally.
So there's a really keen awareness that you always have to be fixing the system. Things corrode, they rust, they get to where you turn them on and nothing happens. But it is so totally used in every nook and cranny that making any accommodation to shut it down, to do something to it, is very difficult.
Two massive underground tunnels, called simply Tunnel 1 and Tunnel 2, provide most of the city's water supply. They run hundreds of feet below Manhattan, far deeper than the subways. Built at the beginning of the 20th century, they are concrete-lined and bored through solid rock. They could last centuries, but the mechanical equipment within them will not. Engineers in the 1950s discovered rust on the tunnel's valves. There were concerns that if they closed the valves for tunnel inspections, they may never open again, leaving New York City without water. So they chose to keep them open. As a result, there has not been significant inspection, maintenance, or repair of the tunnels in decades. No one knows their current condition.
Currently, City Tunnel 1 and City Tunnel number 2 would be feeding each half the city. So you'd lose half the city if you didn't have a replacement.
Without half of its water supply, the city would shut down. For nearly 40 years, New York has been in the process of constructing a solution.
This project is Water Tunnel number 3. We started on this project in 1969. I'm a sandhog. I've been a sandhog for 37 years.
Sandhogs are the men of Local 147 who work deep below the city. They began building the infrastructure of New York in 1872. From the subways to the sewers, the water tunnels to the highway tunnels, New York City thrives because of their work.
We got one little hole in the ground and nobody knows we're here. City Empire State Building, right? That's 1,000 feet, so you figure you go down 1,000 feet. How high that is, that's how far we go down.
Stretching more than 60 miles under the city, Tunnel 3 is taking generations of workers to complete.
I don't even want to imagine what my father had to go through. When we first started, it was a rough job. Everything was dynamite. Now they have these machines called moles. That's like a big drill, and it just cuts right through the ground. So there's no more dynamite. And it's still a rough job, but it's gotten to a point where it's a lot safer. You know? In the 70s, we lost a man a mile, basically. Here, maybe we've had 2 or 3 deaths in the last 20 years, which is too much anyway, but it's cut down a lot.
City Tunnel number 3 will be an opportunity to take City Tunnel 1 out of operation and rehabilitate it. City Tunnel number 1 had 1 valve to shut off the whole tunnel. City Tunnel 2 had 2 parallel valves. City Tunnel 3 has 32, so there's much more redundancy.
We're targeting a completion date of 2012 for Tunnel 3, and we already are starting to prepare to take Tunnel 1 offline.
The construction of Tunnel 3 is vital for maintaining the sustainability of New York's drinking water infrastructure. but the pipeline is useless if there's not a reliable supply of clean water within it.
The city bought up land around the reservoirs to prevent it from development. It provides assistance to local residents to see that there is no pollution of the reservoirs.
It's much more cost-effective to prevent pollution and to protect a source of water than to remove it at the drinking water treatment plant.
What EPA said to us was, you can have an exemption from filtration if you keep this undeveloped and if you can manage the wastewater so that it does not pollute your water supply. And we feel that we've reached the point where we can really keep it clean enough to drink unfiltered for the indefinite future.
And New York City is in a small club of cities that actually have that filtration avoidance waiver.
While municipalities are responsible for maintaining systems and source supply, the standards that protect water are established at the federal level.
There are two important pieces of federal legislation that were both enacted in the early to mid-1970s. The first was the Clean Water Act, which acts to protect rivers and lakes and sources of drinking water. The second was the Safe Drinking Water Act that provides federal standards to assure the safety of the water that we drink. Both acts have been amended since they were first adopted, and they're both cornerstones for the water issues that we face in America today.
The Clean Water Act set a floor and basically said everybody who's discharging is going to have a permit and to achieve this, defined performance level.
The Clean Water Act regulates the discharge of pollutants into surface waters across the nation. It protects our watersheds, our recreational waters, and our drinking water intakes.
Today, more than 50% of the nation's waters are fishable, swimmable. That's almost doubled since the Clean Water Act was passed in '72.
Another significant component of the Clean Water Act was a federally funded grant program to build wastewater treatment plants to reduce pollution in the waterways. And many cities built their treatment plants with this grant money.
But not even a decade after it was enacted, the Reagan administration came in and cut the grant program to a loan program, and funding diminished over a period of time. Now, we still have a third or more of the nation's streams and lakes that don't meet the standards of the Clean Water Act. We have to advance the cause. That is the big challenge ahead of us.
You just don't think of raw sewage in waterways in a developed country, and yet that's what we have, and not just in Pittsburgh, but all over.
Pittsburgh is situated at the confluence of the Allegheny, Monongahela, and Ohio rivers. These three rivers are vital for industry, recreation, and drinking water. And each year, billions of gallons of combined sewer overflows discharge directly into those rivers.
We're now having to face the consequences of the choice that was made to put in combined sewer systems.
In 1994, the government adopted a combined sewer overflow policy to reduce CSOs nationwide. Cities with combined sewer overflows now face an enforcement action called a consent decree. Under a consent decree, a city must reduce pollution levels significantly within a strict time frame or face heavy fines.
In 1960, the combined sewer overflows were a perfectly legitimate way of dealing with sewers.
The mindset was that, what did it matter if we were sending our waste downstream? Water was a good conveyance for pollution.
Sewer systems are installed to reduce public health problems. Now what you're doing is transferring the problem. You're transferring to downstream cities. In addition, cities and towns above Pittsburgh were doing the same thing. And then they were affecting the water intakes of Pittsburgh.
90% of this region gets its drinking water from those same rivers that we have overflows occurring.
We have sewage overflow with as little as 1/10 of an inch of rain, and our average storm here is a 1/4 inch storm.
Over a year's period, 16 billion gallons worth of combined sewage and stormwater overflows into our rivers.
It's not a problem of point X and point Y alone. This is a watershed problem. A watershed problem.
The watershed encompasses many municipal boundaries, and it doesn't know any local politics.
In the Pittsburgh system, 83 cities and towns use the same sewage treatment plant, Alcosan. So, all 83 municipalities have to work together to address the problem.
We know we have billions of dollars that will have to be spent over the next 15 to 20 years. You can't do that wisely when you have 83 separate government agencies making decisions. The municipal consent orders and the Alcosan consent decree require that the municipalities participate in a long-term regional wet weather control plan.
The information gathered in the initial research phase of the wet weather control plan will inform the large-scale infrastructure overhaul. And as this research moves forward, Pittsburgh is also working with environmental groups that are cleaning up the watershed.
Make that connection.
You mean like a mural like on the side of a building?
You know, $5 to get in.
There's water flowing under the ground right now. I mean, I really think a lot of people don't know that.
That's a critical area because everything that's dropped on the ground is part of your watershed now.
We have a very big focus on citizen engagement and community involvement.
I guess I'm thinking it's applicable beyond just this boundary.
We see that as the most important long-term investment.
You don't really get anything done until you start charging people for
Why not? Why not?
They're not subsidizing that. They're not incentivizing that.
Every individual citizen is part of the problem, and therefore every individual citizen has to be part of the solution. Those are the street trees we want people to be planting. We do a lot of tree plantings. All of you must intuitively go, of course it's good to plant trees. Of course I want to put a rain barrel on my house. But is there a measurable environmental impact? Trees are going to take up a lot of stormwater over time and are kind of a long-term green investment. We've had more than 200 volunteers come out planting street trees. We need people to make active changes on their property. And to reduce the amount of flow that's going into the combined sewer lines, we're trying to install 4,000 rain barrels.
Homeowners can disconnect roof gutter downspouts from the sewer system and divert the stormwater into a rain barrel.
The rainwater then can be used to water lawns and gardens and infiltrate back in the ground slowly rather than being piped to a creek where it disappears moments after the storm's over. It's being held within the watershed and helps regenerate groundwater and stream flows.
And that's part of what we're going to do this afternoon is think about how to get more of those people involved. If there's less water in the streets, there'll be less water in the pipes, less sewage overflow.
In addition to mobilizing individual property owners, the Watershed Association undertook a project to restore the 9 Mile Run stream in urban Pittsburgh.
The urban impacts on that watershed have been enormous. Flooding flows, combined sewer overflows, gave it the nickname of Stink Creek for many, many years.
Before the stream restoration, when you have a rain event, the stream would just be barreling, just filled with tons and tons of water, and the water would move very quickly, eroding the stream banks further.
The rushing water ran all the combined sewage straight into the Monongahela River, which is a main supplier of drinking water for the region.
What has happened because of the restoration is the water overflows its banks, it floods into these nice floodplains with native plants, and then slowly the water percolates back down into the stream.
This allows the land to naturally filter and clean the sewer overflows before they enter the river. The restoration included extensive environmental changes to improve the stream and infrastructure changes to reduce the CSOs into the watershed.
When I first started talking with people about stream restoration, they kind of imagined people out with shovels and small scale. This was a massive $7.7 million project.
9 Mile Run watershed is the most significant urban watershed restoration ever done in the United States.
Small-scale projects like 9 Mile Run have far-reaching environmental impact. But they're just one part of the regional wet weather control plan.
This region needs to solve its problem by 2026. And that's not that long away. This is the largest public works project ever undertaken in this region.
You're looking at significant infrastructure, either tunnels or storage tanks or treatment facilities.
The cost is about $3 billion.
If you look at some of the other cities that have gone through this, their rates have gone up significantly. The federal government provides a number of grant programs, but the bottom line is, it's not enough. There's a massive need of money out there for wastewater and water infrastructure improvements around the country.
The struggle for funds is as great in small towns as it is in metropolitan areas.
The federal government has let down municipalities. The first investment under the 72 Clean Water Act was to deal with the biggest waste streams. And after a period of 6-7 years, to then go to municipalities under 250,000 population. But that was just about the time when the federal government converted to a loan program. So smaller sized communities have had to deal with repayable loans, a larger cost on a smaller tax base, on arguably less affluent communities.
Sewickley Township is a rural farming community. However, Hermione itself would be considered to be the downtown area of the township. It's the agways, the auto parts store, the bank. It's your typical small town village.
People think that rural areas are pristine and perfect and everybody has a nice, simple life. That's not exactly the situation here.
When you come into town in the summer, you know you're coming to Hermione.
The aroma in 90-degree days can sometimes just want to knock you over.
We have water, we have power, we have gas, but we have no sewage. I guess when they laid out the town years ago, it just all went into the pipes and straight into the creek.
I've lived here 43 years in the same house. When I moved here, they told us that sewage would be here shortly. And here it is 43 years later, and we still don't have it.
My husband and I went to the first meeting. He always said, "Boy, I'll never see it in my lifetime." Well, my husband passed away last December.
Right now, the wastewater in Hermione is going to basically 3 places: in the street, down mine shafts, or into the creeks. I think we're very lucky that we haven't had some kind of serious health problem.
I came up one morning to get my newspaper, and there was this pool of stench up here. There was a pipe spouting like a fountain with everything coming out. Everything was on the road already. I could see toilet paper. I could see other things that you would put in sewer.
Well, I was actually born and raised in Westmoreland County, so I have been aware of the conditions in Hermione all my life. Hermione has declined because for any type of business of any size to come in and create jobs, they need the infrastructure there. And in Hermione, it's just not there.
To address community frustrations, Sewickley Township, home of Hermione, created a sewer authority board in 1998. It's comprised of residents and business owners who worked for almost a decade to get sewage infrastructure for the area.
We were novices. I don't think anybody in the township knew where to go. And we were frustrated at times. We thought we were right on the cusp of getting funding, and then something happened and we didn't get it. Yeah, we could go out and float a loan, and probably people would be looking at maybe $100 a month in sewage bills. So what you have to try to do is get enough funding to keep sewage rates at a reasonable rate so people can afford them. And that's been a real problem. Without grant money, it can't be done.
They were in line waiting for our money. They had an application on my desk, but when someone has no funding, usually they sit and wait. The problem is the amount of money given in the federal budget and the state budget is just not enough to fund infrastructure. We have a $200 million backlog on my desk alone, and that would be our entire state's allocation for 4, 5, 6 years.
USDA asked that I go to Hermione and provide an independent evaluation of the problems to determine if it was severe enough to warrant funding. I've worked in a lot of communities in Pennsylvania. I've seen a lot of things that were pretty startling. However, the trip to Hermione absolutely astounded me. I wrote a letter to USDA saying that it was the worst thing I'd ever seen in Pennsylvania, and that if they could award funding, that they do so. And they did. They did. Over $15 million grant and loan for that project.
And it took years to get funding. What kept this project going was the steadfastness of the community. They knew they needed sewage, and they just kept plugging along till we got through every issue that came up.
The project will consist of 44 miles of line that we're going to put in and a treatment plant.
It will permanently eliminate the problem, eliminate the health hazards. I anticipate a definite regrowth in Hermione, and it'll be a good thing for everybody.
Maybe it won't help me too much because I'm an old lady, but whoever comes along after me will get the benefit.
There's nothing isolated about the Hermione situation. It's a very common problem. It's a town that was built before current standards. This is not backwoods rural America at all. It's just an unfortunate situation that was created probably 100 years ago or more. And the people have to pay for it in a big way now.
Over here, too.
Because the government is choosing to spend its money elsewhere right now, there's very limited money for communities to install adequate drinking water and wastewater, and I think it's criminal. That's my feeling. This country has to get its priorities right, and they're wrong right now.
Hermione faces problems because of the way its residents laid out the town generations earlier. Across the country, many other cities and towns deal with the unexpected consequences from their early infrastructure design. Los Angeles County is a land of sprawling development. With development comes hundreds of square miles of concrete, leaving no way for water to naturally soak into the ground. In areas of such widespread urbanization, flooding can be devastating.
Back in early 1930s, there was a flooding that took a lot of lives and property. As a result, the city of Los Angeles, in order to protect future flooding in the city, they decided to take the Los Angeles River and make it a flood control channel. They concrete the walls of the river in order for water to get to ocean much faster.
Cities throughout Southern California converted natural rivers to these concrete channels, part of their storm drain systems. This allowed expanding development without the need for large floodplains.
The Los Angeles River is approximately 51 miles. Concrete reduces the size of the river that you need to carry the water because it speeds up the flow of water. If you like to remove all the concrete and to have natural system to carry the water to protect you from flooding, you need to have almost 1 mile on each side of the river set aside for transport of rain. So in order for the city to have use of those lands around the river, concrete made it possible to have minimum land so the water can be carried to the ocean in the fastest possible way. But unfortunately, because of population growth and poor housekeeping, people are putting a lot of pollutant on the streets, and the streets are the openings to our stormwater sewer system. In an average year, 4,000 to 5,000 tons of trash ends up in Long Beach.
We've created a system to deal with flooding, but inadvertently created a pathway for pollution to get into our waterways.
Los Angeles County is beginning to develop ways to reduce the infrastructure's impact upon the environment. On the front lines of protecting the beaches are the crews that clean out the stormwater system.
This big Vactor truck works on the same principle as your vacuum cleaner in your house, only this thing sucks up the whole house. Some of the storm drains collect a lot of trash. I started cleaning drains in '93. They were horrible because they hadn't been maintained so much. Now this is a priority. You have trash, animal waste, and it ends up on our beaches. That is a health risk. That is one of the main reasons why we have to close the beaches after heavy rain.
But even when it's not raining, water still enters the stormwater system, carrying pollutants.
Here in the West Coast, a lot of our storm drain systems are separate from the sanitary sewer system. So you dump something in a storm drain, it goes right to the ocean untreated.
We haven't had a major rainstorm in the last year or so, and yet there's a lot of water in this creek here. I would say 20% of it is natural, and the other 80% is runoff.
The purpose of the Smurf is to treat dry weather runoff, which is coming from storm drains. Dry weather runoff occurs when people waste water through washing their cars in the street, hosing down sidewalks and parking lots, of their irrigation systems overspray.
In a city of 12 million people, those seemingly small bits of wasted water accumulate to enormous amounts.
So all that ends up in our streets, ends up in catch basin storm drains, into our storm drain system, and for some of the city, parts of the city, it ends up here at Smurf. 350,000 gallons come here on a daily basis, producing recycled water, and that can be reused for landscape irrigation and indoor toilet flushing. The pumps can only handle so much water, which is generally, when it's not raining, the dry weather runoff. So if you get a storm of a decent size, the pumps will shut down automatically, and the water will just continue to flow out into the ocean. And it carries a lot of bacteria, and people can get sick when they're swimming in the water near a flowing storm drain.
Everyone knows you don't go in the water for 72 hours after it rains. You just don't. This is the dirtiest beach in Southern California, Doheny Beach. I've surfed this twice. I've gotten sick both times.
San Juan Creek, a concrete flood control channel, flows directly to Doheny Beach.
The concrete you could almost think of as a big water slide for pollutants to go to sea level.
If it rains more than 0.2 of an inch, the county puts out a health advisory for all beaches in the county. That totaled 75 days in 2006. So it's sort of a frightening thing that it's so polluted that every time it rains, we have to stay out of the ocean for 3 days.
To be sick after surfing isn't like, oh, I have a runny nose and tomorrow it's gone. It can be a lot of different things.
They include gastroenteritis, which is an upset stomach, and sinus infections, ear infections, eye infections, and there's also virulent versions of streptococcus that can actually cause severe illness and even death.
Our goal with Surfrider Foundation is essentially to have the city understand that the water is in fact dirty and then work with the infrastructure and the various issues to change that.
But building more systems and more plants can't work alone as a sustainable solution. And as in Pittsburgh, as in New York, part of the answer lies in protecting the watershed.
We need to reduce the amount of impervious surfaces in our watershed, which are surfaces that don't let the water soak in, and then create more pervious surface, whether it's by having driveways that allow water to soak in or different landscaping, to try to eliminate the amount of runoff that comes off our land so that the system, even with the development it has, acts more like a natural system and filters that water. Water quality and sewage infrastructure isn't the sexiest of political agendas, but by raising the awareness about water quality issues, we can create political pressure to get our issues solved. About 15 years ago, Surfrider activists were protesting a beach for being polluted. The city council asked the police to escort them away. There was complete denial of the problem. 15 years later, water quality is on the agenda of every city council person in that local city, and that's completely a result of activists forcing the issue. Surfrider and other local groups saying, hey, these water quality issues are real and you need to address them. And only until the public sort of creates that will the politicians respond.
While some cities deal with infrastructure issues, others have concerns about the sustainability of water supplies.
It's not just about the sustainability of the assets, it's about the sustainability of our water resources. Parts of this country that thought of themselves as water-rich 20, 30 years ago now are discovering that they really are not water-rich. They have source supply issues. They have serious questions about how they're going to accommodate additional growth in their communities.
If we can find alternatives, we can preserve a water supply. Conservation of water is a way of generating more water.
We think that a household can actually reduce its water usage by about 30%. And that's hugely important in terms of the amount of infrastructure that community is going to require.
Las Vegas is one of the fastest growing areas in the country. It's a relatively new city under constant construction. But because it's in the arid Mojave Desert, the challenge of Las Vegas is supply.
All the growth and everything that's occurred in southern Nevada has been with Colorado River water. Without it, the West as you know it today couldn't exist.
To sustain their growing community with this limited supply, Las Vegas learned to be extremely efficient.
This is a desert, and it has its own beauty, but you have to get beyond what you're used to. As long as people recognize they're moving to the desert and give up this notion that they have to bring eastern vegetation with them and make the necessary adaptations in their own life, desert communities can continue to live.
The biggest water user in the desert is turf. Turf uses a lot of irrigation and uses spray irrigation. So what we've done here is use artificial turf. You're never going to be able to achieve the look of back east or the look of, say, California with subtropical plants, but our landscapes are still lush and use about 30% of what the subtropical landscape with turf would use. Las Vegas has adopted a drought-tolerant ordinance. We're using less water today than we used 5 years ago, despite over 300,000 new residents. I think it's a pretty amazing example as to how a town can really turn on a dime if there's the political will and if the public gets behind it.
Even the casinos and resorts have adapted to efficient water use.
The Las Vegas Strip uses only 3% of all the water that we deliver. And when you think about it, it's the largest economic driver in this state, the largest employer, bar none. They knew they had to go the extra mile, and they've embraced conservation, and it's almost beyond belief that they're right now in the process of building another 15,000 rooms. Southern Nevada recycles 100% of its wastewater. So for every gallon we put back in the Colorado, we can take an additional gallon out, or we send it to reuse facilities, and we deliver it to golf courses and parks and other outside applications.
Water is about a third of our budget. That's a lot of money. The lake right over here, 24 hours ago, that was in somebody's house. It's been through a treatment plant, and now it's in our lake and we're watering with it.
These reuse and conservation techniques enable Las Vegas to exist in the desert. Another important form of conservation is preventing leaks.
Every drop counts. All water systems have what they call an efficiency rating. So if you were to measure the water that goes into your system and compare it to the water that goes out, how much is unaccounted for? Most states have a goal of 10%. Ours is at only 5.5% right now. And we have plans to lower that to 4%.
We actually have our entire distribution system mapped out in a computerized or electronic format. We can locate our pipes, we can locate our valves, we can locate water meters that are out there. We've got small units installed in the distribution system, and they actually listen for leaks. We can schedule the repair. minimizes impacts to the surrounding community, and it minimizes costs because obviously if you've got a leak that's been leaking for some time, you're going to see a lot of undermining of the roadways, potential property damage.
All the sensors in the field come into this location. These two operators behind me operate the entire water system 24/7. So we can see all of our reservoirs, their elevations, whether they're going up or down, how much water we're getting from our 2 treatment plants. We try to move it very quickly through the system and serve it to our customers in the most economic and efficient manner.
Las Vegas serves as an example for cities across the country, whether they have a limited supply or not. And many utilities can identify with the struggles that come with maintaining underground assets to support a growing population. One of the most common issues that municipalities share is water loss.
Because it's not a catastrophic issue, we don't think much about it. But there is a 10, 20, 30% water loss through leakage in some systems.
Already treated water that you've invested money in, you're losing before you actually delivered it.
So many utilities are employing the business strategy of asset management. It's a paradigm shift in the approach of attaining a sustainable water infrastructure.
It's not construction of new pipelines. We are talking about maintaining, sustaining the infrastructure we have.
You've got to know what you have, where it is, what condition it's in, and how long you can expect it to last.
We have very little choice because we've invested in a system that cannot be readily changed. You don't leave a lot of flexibility to dig that all up and replace it with something else.
So we have to also teach our students, the workforce, that there is a new science, repair, renewal, and rehabilitation. That's different from building something new. You cannot fix each and every crack in the city. It's like each city you are talking about 3,000, 5,000 miles of pipe. So you have to prioritize where they can go and fix the system.
Each city faces unique situations, so they must determine the asset management approach that best addresses these challenges. Inspections can be done with various technologies, often by a robot, or personally by a technician on a bicycle. Sensors detect breaks, cracks, and weaknesses in the pipe.
We have roots at this cap lateral at 79.
Tree roots can grow into the pipe, splitting it apart.
More light roots at 69.
Sometimes they may even find fully collapsed sections. After gathering the data, utilities can assess the need for rehabilitation.
You have to choose the rehabilitation technique so that the life of the pipe can be extended 30 years, 40 years, 50 years.
Any asset has an optimal investment strategy. If you're making investments in that asset too early or too late, you're wasting money. It costs about 3 times as much to fix the system once it's failed. So it's all about finding that right point where the dollar should flow toward that asset.
But finding the funds to evaluate and rebuild these assets is an ongoing struggle.
There is a gap between what's being spent by municipalities and water supply systems and what needs to be spent. And somehow that has to be made up. So there's a good bit of lobbying through Congress to get funding.
We need to restore the construction grant program. We need to invest substantially more on the federal government side as an inducement to states and local governments to make the investments they need to make.
But the federal role is going to continue to be diminished because of so many competing demands. So the expectation that the federal government will step in and infuse a lot of capital into water infrastructure, I think, is doubtful. And whether they should or not, I think, will continue to be debated.
Where money continues to be elusive, some cities and towns are turning their assets over to private companies, hoping the private sector can find the solutions they cannot.
In the U.S., roughly 90% of all water and wastewater systems are still publicly owned and publicly managed. The remaining 10% are managed by privately held companies.
The private sector has learned to become very efficient, and frequently a municipality can save themselves a significant amount of money by bringing in a private company. This is not true in all cases. There are some exceptionally well-run municipalities, but they do have to deal with a city government system that is very hard to work within.
There's several advantages to municipalities. They don't have to make a profit, so they're generally just trying to be break even. And because of the importance of water, a lot of communities would be reluctant to give up control. But it is being looked at, especially on some of these troubled systems.
Much of the business is in the mid-sized to smaller communities who have even fewer resources than the large cities. Less expertise. If you take options off the table, it'll be, well, what we've done for the last 40 years, and right now we have some real challenges. So any good manager is going to want to have a maximum number of options.
You've got to have a serious conversation with your constituency about what it costs to deliver the service that you're required to deliver and to deliver the service that they want.
I think ultimately the responsibility is going to be down to the user of this commodity. It costs money to operate these systems. There's a need to continually invest in these systems. There's going to be new regulations. It's all going to cost money.
For all practical purposes, people are going to have to pay about twice as much for these services as they currently do. Because a lot of the pipe that went in, a lot of the plants that went in with very sizable portions of federal grant money. Mechanisms that are no longer in place.
Without grants, utilities often turn to the bond market to pay for large capital improvements. And although the loan is often spread over a 20 to 30-year period, user rates will increase to pay down the debt.
Until a community accepts the willingness to pay for what they use, they won't have that money that they need to replace this failing infrastructure and improve their treatment plants so that they can meet regulations and population growth. Elected officials have to have enormous courage to be able to raise rates, to go out for bond levies, to deal with a situation that most people don't even see. It flushed yesterday, it flushed 10 years ago. What's the problem?
Atlanta is a rapidly growing urban area. Its primary source of drinking water is the Chattahoochee River, which also provides water to many downstream communities. But its infrastructure is dangerously old, with outdated facilities and combined sewer overflows polluting the watershed. The city faces strict consent decrees and lawsuits, along with a severe lack of funding.
When I started working for the city of Atlanta in the late 70s, we were approaching that point in time where a lot was going to be needed in terms of rehabilitation and upkeep. Most of the very large pipes were at least 80 years old. We had needs that were identified in the 50s and in the 60s and in the 70s that were deferred.
We are urging that we all try to find a way to overcome the obstacles and the limitations that might exist. When I was running for office, I met someone who knew Mayor Hartsfield, who in the late 1960s said, "I don't know who the next mayor will be, but I know they'll have to fix the water and sewer infrastructure."
The city had chronic sewage overflows into the Chattahoochee and its tributaries. Fecal coliform bacteria levels were in the millions of colonies per 100 milliliter, which was a significant public health threat, and this had been occurring for decades. But neither the federal EPA nor the EPD back in the 90s were willing to take action under the Clean Water Act to make the city fix its plumbing. So in 1994, we started Upper Chattahoochee Riverkeeper. We filed a Clean Water Act lawsuit. In 1997, we won. And so for the past decade, the city has embarked on a program to clean up the river. Now, with 1,800 miles of sewer system, 3 sewage plants, and combined sewer overflows, it took a number of years to figure out what would be the solution.
We are facing a crisis in infrastructure.
A huge change came about when Mayor Shirley Franklin became the mayor of Atlanta.
We're having to choose how to spend our money. I named myself the sewer mayor. And I wear that title very proudly because without wastewater infrastructure and drinking water infrastructure, the economy will stop. That makes all my sense. We did a major outreach. We trained an outreach team who went to every community meeting to educate people on how bad the crisis was. Not only did I tell people that we'd have to raise rates, I told them we'd have to tear up the city to repair this infrastructure.
You can't simply say, I won't use any water, it's too expensive. We have about 25% of our population that's at or below the poverty line. So you have to look at rate structures that are tiered so people can pay their bills.
We would love to have something like 75% federal money. We do get some federal aid and we are thankful. But on the other hand, we're paying for this primarily with new rates. We have increased our rates to among the highest in America, but not nearly as much as if we hadn't passed a 1-cent sales tax dedicated to water and sewer infrastructure.
That sales tax counts for about 1/3 of the revenue of the department right now.
We got 75% of the voters to agree to tax themselves so that their children and their children's children could have clean water because we're investing in it now.
There were no alternatives. The infrastructure was in dire straits. A lot of people didn't want to believe it had to be done, but it had to be done. What came out of those lawsuits by the Upper Chattahoochee Riverkeeper were 2 consent decrees focused on overflows. The intent is, City of Atlanta, you need to keep the flows in the pipe.
With the help of the funding the city raised, Atlanta has been implementing an asset management plan that evaluates and addresses their infrastructure issues.
It's a continuum. At one end, you have your regular maintenance that you do every day on the system, and at the other end, long-term planning so that every year we're repairing, replacing the right things, and we don't have to do it all at once, which is quite frankly what we're having to do in Atlanta now.
We have thousands of assets that we have to keep track of. We have to always know their condition and continuously plan for their refurbishment at the right time. One of the things we are required to do under the consent decree is inspect our system. We're trying to find where there's leaks. So we blow smoke into the sewer pipe.
We're locating places where water from the surface of the ground is running into the sewer pipe and overloading the system.
We have 1,600 miles of sewer. We are evaluating every linear foot of that system. Is the pipe leaking? Are you having a lot of infiltration or inflow?
Every time it rains, water will come down, go into the pipe, enter the sewer system. It's very easy to repair this defect and get all that water out of the system.
With our closed-circuit TV inspection, we record cracks, holes, pipes that are partially collapsed.
We literally will have a digital video of every foot of our sewer that in the future we can go back and do a comparison. What's changed? Is it degrading? What do we need to do? At what rate is this happening?
To really improve these systems, you need to deploy the latest technology.
The pipe bursting process is designed to replace an old pipe without digging an entire trench. The old pipe has cracks and displaced joints and openings in it. We try to stop not only infiltration but exfiltration, where sewage would actually leak out of the pipe. The head is larger, so it breaks away the old pipe and allows the new pipe to come in behind it.
We are saving about 67% of the cost of actually digging old pipe up.
It's less invasive than an open cut process where you would open the whole trench up and replace the pipe. It's called trenchless technology, so that's as good as it gets.
We don't have to dig up everyone's yard, and we refurbish that pipe at a much reduced cost. Another technique is cured in place lining. It's equivalent to putting a large sock through the existing sewer. We form a new pipe inside the old pipe, and therefore we seal up all of the defects that allow rainwater to come in.
We repair about 730 leaks a month in our system.
The improvements that we've made will make the environment better. We had approximately 1,000 overflows occur in 1999. Today, we've reduced overflows by 45 to 50%. And it's going to continue to improve as we go forward with the rehabilitation program that's required under the consent decree.
An important piece of the program is the construction of an 8-mile-long storage tank that will significantly decrease combined sewer overflows.
Right now, we're at the bottom of the Rockdale construction shaft. We're 310 feet below grade, deep under Atlanta and hard rock. In the downtown area of Atlanta, the sewer system and the stormwater system are combined, and there are overflows during storm events. And so the purpose of this system is to relieve that flow, take it into the tunnel, transport it to a brand new treatment plant, clean up the Chattahoochee River.
Instead of the combined sewage overflowing into the river, it will flow into this tunnel that acts as a storage tank. The water will then slowly empty into the new plant for treatment before it's released back into the river.
The system in total is about 8.5 miles, 27 feet in diameter. Most of the time it'll be dry. The only time it'll fill is when the sewer system is overwhelmed by the storm. It is a massive project. Our budget was $210 million. We've worked about 1.5 million man-hours.
It is an incredible amount of work. Our capital program right now is $3.9 billion over a period of less than 10 years.
So it's very expensive. The bottom line is, we as Atlantans, as Georgians, don't have a choice to protect the river. We need to leave it better than we found it. And it's really been a political advantage for me, not a disadvantage. People laugh about me being the sewer mayor, but they remember what I'm doing.
We want people to understand when they see one of our work crews out working on the mains, that work is necessary in order for them to have good, clean drinking water, to have a good, functioning wastewater system.
You don't put a roof on the house one time. You don't fix the plumbing one time, any more than I get my hair done one time. If we don't continue to invest for the next 20 years, we'll find ourselves back at the same point that we were in the late 90s. If we don't protect water, we will be without water. We will be without industry, we will be without jobs, we will be without a healthy economy, and our people will be sick. So we don't really have a choice.
We're going to find out why that's important.
It's a question of who's going to pay, how much you're going to be willing to pay in order to ensure that your children live the kind of life that we as Americans have promised them.
And what we're going to do is get a marble to travel through your pipe.
Keep still.
Oh, there's a clog in the drain.
No, it's not.
Oh, there it is.
In the 19th century, foresighted leadership and innovative engineering established drinking water, wastewater, and stormwater infrastructure that supported the growth of the nation. Through much of the 20th century, we continued to invest to ensure our public health, safety, and economy. But now, in the 21st century, we face the need to revisit our commitment to the buried assets and infrastructure that for so long have provided for our way of life.
Infrastructure across this country needs to be addressed, and it needs to be addressed now.
What we need is responsible stewardship.
We just can't turn a blind eye and say that they're going to continue to work for another 50 or 100 years.
We can't be embarrassed to tell our congresspeople that we want something different.
It's going to take state officials. It's going to take federal assistance. It's going to take all of us to get this United States back where it belongs.
We're not there yet, but we can be there.
Water is America's greatest liquid asset, and citizens and governments all need to be reminded of that from time to time.
What can individuals actually do to make a difference?
We need to accept the responsibility that future generations need to be able to rely on those assets to have the same quality of life that we have.
All the water there ever was or ever will be is here on Earth today, and it's our responsibility now, at this time, in this generation, to protect it. That must be our legacy to the future.
Major funding for this program was provided by
the Colcom Foundation, working to foster a sustainable environment to ensure quality of life for all Americans.
Additional funding provided by the Associated General Contractors of America, the American Society of Civil Engineers and its Environmental and Water Resources Institute, Insituform Technologies, and the National Association of Clean Water Agencies. A DVD of Liquid Assets, the story of our water infrastructure, is available for $24.95 plus shipping and handling. To order, call 1-800-770-2111 or visit mediasales.psu.edu.